Hello, welcome back to AP Pre-Calculus. Today's lesson is 2.12, Logarithmic Function Manipulation. Okay, so hopefully this page does not create any PTSD for you guys. I know that back in Algebra 2, we loved the logarithms unit, but I told you that we were going to see it again. So let's go over a couple of the rules that hopefully we remember. All right, so we can take a single logarithm and we might be able to expand it, right? So if we're working left to right on these things, we call that expanding a logarithm. And if you remember, logarithms are just exponents. So when I write down a logarithm, it's just another way to show an exponent. So if you think about it that way, these properties are fairly understandable, okay? So this is an exponent, right? And this is an exponent, and it's adding. When do we add exponents? When we did some sort of multiplication, right? So when we're expanding, for every factor that's inside the parentheses, each one of those factors gets a log, okay? And we can only write a single thing after a log. It's either going to be a single letter or a single number after a log. We'll never write more than one thing. I wouldn't put a square root of an x. I wouldn't put 5 to the x power. We wouldn't do that, okay? It is only one thing after the log. And if you can get that into your mind, it makes doing these a little bit easier, okay? So over on this one, I'm subtracting exponents, so it makes sense that there is a division idea going on. And this one here is a little bit weird. When we raise exponents to other exponents, like if I gave you this, x to the third raised to the fifth, we would multiply these two exponents. And that's what we're showing in this last one. I have raised to an exponent. I have an exponent raised to an exponent. And what should I do? Multiply the exponents together. So whenever we have an exponent with our factor, when we expand, that exponent goes down in front. And that is the big property. This is the thing that the whole reason that we learn about logs is that property right there. We use these other two, but that's the important one. Okay, for example 1, we're going in the opposite direction. We are actually condensing logs. So we have several terms. They all have a log. Well, most of them have a log. So when we condense, we want to write it as one log with its base. And I like to put a parenthesis. And what are we doing with these two logs, these two exponents? We're adding them. Well, adding goes with multiplying. So we would just multiply it like that. All right. Second one. Put my log base 3 down there. I actually like to look at all of my terms, and I look for a minus sign. That's the first thing I always look for. And before I do anything else, if I see a minus sign, I'm going to put a division bar. All right. And let's think about why we have to have a division. If this is an exponent, what's the number in front of that exponent? Well, it's a -1. So we're talking about a negative exponent, right? And negative exponents go down into the denominator for the most part, okay? So the 5 is a positive exponent, so it gets to go on top. Z has a negative exponent, so it goes on the bottom. And that's how you do that one. It's just as easy with 3. It could be 50 logs. Who cares, right? So I'm going to write log. We don't have to put the base 10 because it's given. If I don't put the base, it's there. I start my parenthesis, and then I look for negative. Oh, I'm going to put my division line. This time I see 2 minus signs. That means 2 of my factors have negative exponents, right? So the x is positive, so it goes in the top. 5 is negative. Its log is negative, so it goes in the bottom. Z's log is negative, so it also goes in the bottom. All right, let's keep going. On D, we have a number there, right? So that's going to be an issue because when I write log, I don't want anything in front. When I am condensing, we don't want anything in front of the log. So we're going to start here. I see a minus sign. We go like that. The y goes in the bottom. The x goes in the top. But what do we do with that 3? Well, remember, we're multiplying the log, the exponent by another. So that 3 must have been an exponent. It would go like that. All right. I see a minus sign, division bar. The only log that's negative is the one that goes with the b, so I'm going to put the b in the bottom. But it also had a 5 out in front, so I'm going to put a 5, right? I wouldn't put a negative 5. The negative forced me to put it in the denominator, and then I don't have to worry about it being negative anymore. The a is positive, but it had a 2, so I'm going to put the 2 up there. And the 4, well, that's terrible. Let's rewrite that. You could have left it like that, but I don't like it. I'm going to put the 4a squared. That looks much better. Now, f is a different one. This is one that we probably never did in Algebra 2. So I want to condense this. This right here, I could write with log base 6. I just have to figure out what that number is, right? And if you remember, a logarithm is just an exponent. It's the exponent that turns that base into that number, right? So they're telling us that the exponent is 2, right? Because there was a log here, it just got simplified down. The exponent is 2 because logarithms are equal to exponents. And if the base was 6 and the exponent is 2, what was the number that has to go right there? Well, it had to have been a 36. So that is log base 6 of 36 plus log base 6 of x. Now I can condense it down. I can write 1 log base 6, put a parenthesis. I don't have any minus signs, so no fraction bar. This just means I have to multiply things together. 36x. Okay. All right, so we got a multiple choice question here. And I am not going to just straight up solve this and write it out. I want to look at some things and get rid of answers right away. If you remember, I said after a log, you can only write one thing, one number or one letter. Well, that wrote 2. So automatically, I am not choosing that guy. Nothing wrong with B right now. Nothing wrong with C. Why is D different than the other two? That one has 3 terms. 3 terms means I must have had 3 factors in the parenthesis. Let's count them. I have an x and I have a y. That's only 2. So I should only have 2 logs. So I know I'm not going to choose D. All right. So what is the difference between these two guys? Well, this 2 goes with both of them, meaning that they both had a squared. Y doesn't have a square. So it's not B. All right. And if we would have just expanded from the beginning, I would have put a log base 3, and I would have put another log base 3 because I have 2 factors in there. The first factor was an x, the second factor is a y. The 2 that goes with the x goes down in front, and then the y was in the denominator. So we could have done it like that from the beginning. I just wanted to go through some test-taking skills with you. All right, example 3. The function f of x equals log of 6x is a horizontal dilation of the function g of x, which is equal to log of x. Let's just review, what kind of horizontal dilation do we have here? Is it multiplying by 6? What are we doing? Remember, when it's in the parentheses, it is the opposite of what you think. So the horizontal dilation would be a 1/6 dilation, okay? But that's not what they want us to do. They want us to write it where we're adding something over here, right? They want us to, so what they want us to do is they want us to take this log of 6x and rewrite it as log of x, because that's the g function, plus some unknown here. So really all they're wanting us to do is to expand this. It's pretty simple. So I would write 2 logs because I have 2 things in there. I have a 6 and I have an x. I don't have any fractions, so everything's positive. And so what do I have to put over here? Well, I'd have to put the log of 6, okay? And that's it. Okay, change of base property. We actually learned about this last year, but we didn't use it the way they want us to use it in AP Pre-Calc. We used it just to evaluate a logarithm that didn't have the same base as what we could use in our calculator. But now that we have these calculators that we can put whatever base we want in there, we're not going to use it for just straight evaluating anymore. We're going to do some weird things with it. So we need to talk about the actual formula and what we're doing here. So look at this craziness here. This is just, it's mathy people trying to look really smart. So we say log base b of x is the same thing as log base a of x divided by log base a of b. What did they do? Well, they put log of x on the top and they put log of the base on the bottom. They took the b away from there and put it here. But they didn't say it was 10. Last year we just said it was a 10. But we could actually use whatever base we wanted to. Like if I said, hey, I have this log base 31 of 700, right? If I just said, hey, I want you to evaluate that, we could just use our calculator and we wouldn't have to do anything hard. But if I want you to write out the change of base formula, we have to do, and we can choose whatever base we want. I'm going to choose base 99. So I'm going to do this, log base 99 on top and bottom, right? And then I'm going to put 700 on the top, and then whatever that little base was down there on the bottom, 31. So that's the change of base formula. Like when we're evaluating, we would never use 99s because that's not on our calculator, but we have a log button and an ln button. For the most part, when you get to calculus, most calc teachers will just do ln, right? Natural logs. But you can choose anything. That they just chose the base e one. It doesn't really matter. So let's look down here at example 4, all right? This is the kind of question that they're going to ask us on the AP test. It says, let f of x be log base 4 of x and g of x be log base 9 of x. We want to show that f is a vertical dilation of g by finding the value of k, such that f of x is equal to k times g of x. So what do we have here? We have log base 4 of x is equal to k log base 9 of x. So what we want to do is we want to make that left-hand side look like the right-hand side, meaning I want to have log base 9, okay? So all I'm going to do is I'm going to take this guy and do the change of base formula using a 9 on the top and the bottom. Oop, that looks like a G down there. 9. And the x would go on the top, the 4 would go on the bottom. So look, I have this guy right here, and I can move him over and drop him down. So if I did that, I'd have my log base x. What's left? Well, there's a 1 out here. So if I move the log base x over to the right, I still have a 1 over log base 9 of 4. So this is k. Because you see how I forgot my 9 down here. So do you understand? Hopefully you can see that. All right, the natural log function. Guys, we've already talked about this. A natural log is just we have common log on our calculator, that's base 10, and we have natural log on our calculator. That's just another log, it's base e. And I don't know why they changed it to natural log, but that's what they did, okay? It's just two of the logs that in the real world get used a lot. You don't have a lot of things that use log base 73 out there, but log base e and log base 10 are used so much that calculators, even older calculators, not like our awesome calculators now, even older calculators have log and ln on them. But it's still a logarithm. So when we're doing any kind of expansion or condensing, it's done the same way, all right? So that's what we're going to do here in example 5. So example 5 is just a multiple choice question. We basically want to condense our 3 ln x minus 4 ln x, okay? So let's cross some things out because I like this idea. What does it mean when we have a minus sign in a list of logarithms? Does it mean that we should minus things? No, it's a negative exponent, which should give us the idea of denominator stuff. So these two cannot be it. They don't have denominators, but the other guys are there, okay? Let's look at this one. If I told you that I wanted you to expand this, how many factors do you have here? Well, 3 is a factor, x is a factor, 4 is a factor, y is, that's 4 factors. This would have to have 4 natural logs, right? Remember, 3 times a natural log. We're multiplying exponents. So that gives us the idea of raising it to a power. Okay, so the answer is A.